Assalamualaikum semua, salam sejahtera. Terima kasih sebab sudi hadir hari ini. Uh, kita mulakan dengan bacaan Al-Fatihah. Kita buka majlis dan saya baca doa sikit ringkas saja. Allah alaina, ya Allah bukakan ke atas kami, wa maftah alaina hikmatak, rahmatmu, wansur alaina, dan limpahkan ke atas kami min khazain, daripada khazanahmu, rahmatik, rahmatmu, arhamar rahim, yang maha pemurah, yang maha pengasih. So sebelum saya mula, saya nak menjemput Prof. Malia, Dr. Leong Chun Yung, penyelaras kurs kaedah penyelidikan dan seminar industri bagi program sarjana dan data analitik untuk memberi sedikit kata-kata aluan. Silakan Dr. Leong.
Terima kasih Fatimah selaku pengerusi majlis dan juga moderator kita pagi ini. Yang berusaha Encik Zuhri Zuhud, penceramah kita, saya hormati. Profesor Madia, Profesor Madia, pensyarah, pelajar dan tuan-tuan hadirin yang saya hormati sekalian. Selamat datang ke seminar Sains Data dan Analitik yang merupakan sesuatu yang penting bagi pelajar-pelajar Sains Data dan Analitik, khususnya pelajar sarjana Sains Data dan Analitik, yang mana tujuannya untuk mendedahkan mereka kepada isu-isu semasa dan penjagaan terkini dalam bidang Sains Data. Jadi salah satu daripada objektif utama seminar seumpama ini adalah untuk mengetengahkan kepada pelajar tentang isu cabaran dan praktis berkaitan dengan Sains Data dan Analitik yang digunakan oleh para pengamal industri. Jadi sesungguhnya kita berusaha pagi ini sebab Encik Zuhri merupakan seorang pengamal industri dan dia mempunyai pengalaman yang luas juga kalau kita tengok dari segi latar belakang dalam teaser beliau. Jadi selain daripada itu, kita juga ingin menekankan kepada perkongsian idea mengenai metodologi yang praktikal dan sistematik yang merangkumi perolehan perkakasan, peristian dan bidang pengetahuan utama perlu ada untuk menyokong pelaksanaan projek sains data. Jadi diharapkan dengan seminar seumpama ini, pelajar akan terdedah kepada amalan-amalan dan praktis yang telah dilakukan oleh para pengamal industri yang sebenarnya. Jadi seterusnya saya mengucapkan banyak terima kasih kepada semua yang telah menjayakan seminar kita pada pagi ini, yang telah berusaha menyediakan kemudahan para pelajar dan juga pensyarah membantu. Dan seterusnya saya kembalikan kepada Dr. Fatimah selaku moderator majlis. Terima kasih Dr. Fatimah.
Terima kasih Dr. Leong. Okey, tanpa berlengah lagi, kita boleh terus mulakan dengan saya serahkan majlis ini kepada saudara Zuhri. Saudara Zuhri.
Okay, can you see my screen and can you hear me?
Yes, loud and clear.
Yes, thank you so much. Dr. Leong, I just want to say your speech just now, wow, that was so motivational to hear.
Thank you very much.
It's such a grand speech. Thank you so much. Yes, I am actually a practitioner. I strongly believe in balancing theory and practice. So, and you mentioned about students. I feel that when I was a student, I didn't get the chance to hear from people from the industry and how they apply computer science. So I hope that that is something that I could do or achieve with this talk. So that's actually one of my personal objectives. Yeah.
Thank you very much. Thank you very much.
So I'll start with the title. The title of the talk is Network Science in the Industry. Yes, it is the application of this particular field. So I'm gonna go to the next slide. Okay, my name is Zuhri. I hope that everyone has seen my background. You guys can just call me Zuhri. It's no need to be super formal about it. I'm very, very open-minded about these sort of things. Now, here's the outline of my talk. Now, I didn't take this from Star Wars. Maybe they took it from me. This is the outline of my presentation. Always we have to define the definition. What is the plot of all this particular field, network science? You have to define it first. Yeah, and you have to define it well. After you have defined it, what is actually the problem? So after I have defined what network science is, I'm going to talk about bad data. So bad data It's not something new. Okay, this has been ongoing for many years, many decades. Due to the advancements of technology, for example, cloud computing. Nowadays, you don't really have large servers installed in some room. You just subscribe the server from, for example, Amazon or through online. So although the technology changed, the bad data is still there. Okay, although it says the beginning, this is the landscape. Previously, it was there, now it's still here. Although you have advancements, it's going to catch up back. So this is the beginning up until now. I'm going to explain what is bad data and how it's affecting us even now. The middle, okay. Analytics is not new, okay, but it's catching up right now. For some reason, it's booming. Data science is booming, and data science, the term is not new as well. It's borrowing heavily from statistics. But for some reason, we are seeing a large boom in data. But then it goes back to advancements of technology, for example, cloud computing. Okay. So, and finally, I will say what is the difference between the return of the analytics and the rise of analytics.
Guys, after I graduate.
So for the return, one of the many analytics model that we use is machine learning. Machine learning was there in the 80s and 90s, similar to network science. Network science is not new. So it's returning now due to the advancements of technology. It's rising and rising and rising. So this is my outline of the talk. Okay, so let's start with the plot. So now we have advancements of technology, but we have to understand what network science is first, really. If you don't understand it, what's the point of using it? Now, the plot. We hope that with the advancements of technology, network science, complex networks, and graph theory can still contribute to knowledge and the practicality of the industry. But whatever it is, we define it first. Now, before I define network science, I need to define what's a network. There is some controversy, some drama about the difference between network and graph. For this talk, they are the same. Okay, so a network is basically any phenomenon, and this is something that is actually correct. Anything that you want to find a connection, you can use network. Okay, but then, okay, so that's very simple. That's a simple definition. If anything you mean like family, businesses, financial, stock market, if there's a connection, can I use networks? Yes, you can. Okay, so what is the difference between networks and network science? And maybe what is the difference between network science and graph theory? And there's another term for complex networks. So we are going to see the definitions. Okay, this is the name of the field, network science. Network science is a really large field. It's a mother field. Network science has a few subfields that it used from what we call established fields. 3 of them. Graph theory is one of them. Computer science is one of them. Statistics is one of them. The heart of network science is all absolutely graph theory. Without graph theory, there's no network science. Graph theory studies any abstractions that involve connection. If you are studying the abstraction purely of the sake of its mathematical properties and its connection, then you are studying graph theory. Or that's why a lot of time graph theory is placed in pure mathematics. But if the graph grows larger and larger, it's very hard for humans to actually calculate. So with the advancements of computer science, we develop algorithms to actually assist in this calculation. So graph theory and computer science are strongly connected. Although graph theory is mostly on the pure maths, computer science is more on the applied maths. But these two need each other because graph theory, you mathematicians, if you are out there, new theorems will be used by us, computer scientists. We don't develop those theorems. We just use them as an algorithm for the machine to compute. Now we have graph, which is the main basic concepts from network science. We have computers to actually compute them automatically. We need something to describe it. So that's why we have statistics. From my opinion, statistics is the original data science. Without it, this field alone has a subfield called descriptive analysis. It's describing the data. Without this particular field, you cannot really describe large amount of networks. So these 3 are interconnected with one another. But that is not the completion of network science. These are just the subfields of network science. Combining these 3, theory and practice, and if you apply in real practical problems, you will have what is known as complex networks. If you combine these three and you are trying to solve real problems, for example, COVID networks, okay, this is known as complex networks. So it's basically applied graph using computer science and statistics. So all this, the understanding of these fields and the applications of it is what is known as network science. It's a really large field, multidisciplinary, and I know there are some other subfields that I have not defined, but these are the main ones. Okay, now this is the definition. So now let's move on to networks again. I said just now networks in business. Okay, obviously in industry and business, they are basically interconnected. What do I mean by business here? Now, most people will associate the word business with financial transaction or profit and loss. But business has a very broad meaning behind it. Business can be any activity. For example, your personal life is your personal business. So when we say networks in business, it can be anything, any activity. That's actually a strong claim. We are saying that networks can be used to model anything. Yeah, it's true. That's why we defined just now any phenomenon that has any connection can be used in network science. Okay, now we have defined the definitions. We have defined business. Again, for this talk, business can be any activity so that we know the widespread use of network science. But we need to know the application of these sort of things. Okay, so now we have understand the definition, we understand the plot. Now the beginning. Now, we know that network science is a field that can be used for any data that involve connections. Okay, but what would be the challenge for this particular network model in the industry? The challenge for networks in industry is not far from the challenge that is facing by academics, to be honest. Now, let me give you an example. First of all, what is bad data? Well, bad data is just a term. It can be anything. It can be just bad data. It can be bad process which actually invoke the bad data. People problems, people are not really skillful or they just don't know what analytics is, contributes to the bad data. We have ethical issues, for example, misrepresentation, fraud. These are all bad data. It's just a term to describe something that is not good. Now let's look at a business case. Look at it. One business you probably have used, but didn't realize you're using network science. Now again, I said network science is large. Now, how is it possible that this very huge field that you can use for something very small? Okay, let's prove that, shall we? Let's have a business case. Again, business is any activity. When we define something in the industry, you must have a case. What do you want to do it? So you have to define your activity. So this particular activity is an office, not gossip, politics network. This is actually from a research from one of the many papers in the academia, but I'm making it a bit broad. The business case here is getting visibility of the boss for that promotion. Okay, and why getting visibility? Because that's the only way from this business case to get that promotion. It's not through hard work or talent. So this is obviously some sort of an assumption and some sort of fact. So let's build a network for you to approximate how close you are to that promotion. The edges is the flow of favors. For example, I help you, you help me, or boleh tak awak tolong saya sikit? Kalau awak tolong saya tolong awak. So that's the edges. And the nodes are the people, the staff involved in that politics. Okay. Okay, so these are the nodes. You have a boss with a big nose. We have a city here that might be some administrator. We don't really know. She looks like the typical administrator. We have Mariam here, who is the typical Instagrammer. We have Raj and Ong here, who probably have a very nice LinkedIn profile. We have Abu and Johan, who probably are friends. We have Samad here, who probably a very senior staff member. But now, all those information that I said just now, the typical administrator, the Instagrammer, the nice profile, LinkedIn, the friends, are those important for you to get that promotion? Or are they just noise? Or should you use that? Or if you are using that, would that contribute to your promotion, or is just bad data? So this is something that we have to consider, not necessarily in the industry, but also in academia. But this one example, this is obviously a political example, is how the large field of network science can be used in something super trivial, but at the same time can be very beneficial to you. Now, let's go back. How do we solve this? You want to get that promotion to your boss, right? So you, who has the skills of a data scientist, so that's actually very valuable. And if you know what business intelligence is, that's really going to help you. Business intelligence here means that you use large amount of data with data science to come to a conclusion. So that conclusion is basically data driven. It's not some mere opinions or emotion. It's based on data, good data that you have. So this is business intelligence. One example of business intelligence is the number of COVID cases. You see those dashboards or reports, they have numbers there, like I think Selangor has 3K. So they got that data somewhere. So the government is using data to derive strategy and make a more intelligent decision or intelligent business decision. Again, I said just now, business is an activity, not necessarily financial transaction. So what the government is doing is business intelligence. They are driving their policy based on the data. Okay, so, but we are talking about you now. You have the data science skill, you have the understanding of business intelligence, and you are a strategist. And this is a very important word. If you're a strategist, you always think long term. If you are not a strategist, you are thinking short term or tactical. Strategist means 2, 3, 4, 5 years. You think ahead. You use your business intelligence skills and data science to think ahead. Now, why do we have business intelligence as strategy? Cost, and more cost. For example, the government, if they are not using business intelligence, COVID cases will increase even more. We will lose more money, we will lose more time, we have more effort to actually end COVID and other things. It's always about cost. Again, I said business is any activity. The business of dealing with COVID is actually very costly. It involves money, time, effort, and etc. So that's why you need to have business intelligence. You need to have strategy. What is the long-term goal here? You cannot have a short-term goal. And I understand there are students here, so I'm going to give you some example for students. Suppose some of you undergraduate students or those who are interested to do your master's. Suppose you enroll in UCAM. You have no idea why you want to enroll in that master's program. That is actually very risky because during your first semester, you probably get lost. The potential of you dropping out is even higher because you have no strategy. You have no long-term goal of why you want to do the master's. Maybe your second semester is better, but still some hiccups here and there, but you still don't know why you're doing it. The worst part is during your final year. If you want to do your thesis, you have no idea what you're doing, and you probably are going to give problems to either the university or your supervisor. So having a strategy to do this sort of very expensive investments, because master's is a very expensive endeavor, is very important. So this is for your undergraduate students. If you have a good strategy, that does not mean that you won't have hiccups. You probably would have some as well, but it lessens the impact. So that's why you have to have a strategy. And if you are very well versed in business intelligence, you have the data, you articulate your data based on statistics. For example, the ranking of the university is good, and you use that data to make the decision, informed decision. Maybe hopefully you can make an informed decision. In the real life, the government is doing it for their COVID cases. In the industry, we 100%, we always have to have a strategy. We always have to have a town hall session where the executive will tell us that this is the direction of the company. If not, I don't think people will stay in that company. Okay, so that's why we have a strategy and business intelligence. Now, since you are a data scientist, you have the skill of business intelligence, you are a strategist, now you are ready to tackle that promotion. How do you know that of all these people, they can get you that promotion? At the end of the day, it's still, you want something out of it. In this case, your promotion. Okay, how network science is used is not dissimilar between academia and industry. Network science is used for abstractions. So we have a lot of problems, or we have a lot of information. How do we solve that problem? By hiding things that we don't need, and we focus on only things that we need. So that's abstraction, the core idea of abstraction. We abstract the things, we remove unnecessary details, and we just focus on the things that we need. Once you understand that, and you can use network science for it, it's basically a paradigm of a way of thinking, and you can apply that as a strategy. This is something that we do in my current place. We use network science to actually lessen unnecessary information. We don't really need those sort of information. We remove them, and we will make network out of it. So that's the strategy and the mindset. Visualization. Network science, the great thing about network science is the visuals. It's always attractive to show people the network. So if you show this to executives and they get a reaction to it, either positive or negative, if you get a fast reaction, you have your ROI already. You just need a reaction. If you don't have a reaction, then leave the talk, then you don't have a ROI. It's not really a good strategy. So this is how we do it in the industry currently, high level. So going back to that trivial example, although trivial, is actually very very beneficial to a lot of people. So your boss has a very large nose for some reason. You assume CT is probably the typical administrator. You also don't know that. You say that Mariam is your typical Instagrammer, have very shiny profile, friends. Is that important? Well, you have to analyze that, but now we need to know the necessary information first. So we remove all those really petty information. We abstract it. This is one example of abstraction. We don't really care your boss has a big nose. We do care, however, that you can get that promotion from this network. So this is one good example of abstraction. We hide that information. Now, back to the business case, this is a simplified version. We want to create a network to approximate how close you are to that promotion. You know that you can get that promotion if you have a connection with certain individuals. Suppose you spend 3 months making that connection, you know that these people can get you visible to the boss. Okay, but let me explain this visually. This is what is known as a bidirectional graph. These are two nodes. These are basically two people. Bidirectional graph means both of them are basically interconnecting with one another. This is a unidirectional. It's just this guy here. He wants help, but you cannot get help from him. This one will help each other. This guy doesn't want to help anyone. Okay, so he's basically, sometimes we have people who are very strong in their principle or they are just loners. Okay, so you've analyzed the landscape, and these are the network connections that you have constructed. Now, first of all, we see cliques. Raj and Ong. Raj and Ong might help each other, or they will help each other. These are basically your clique, but they are very far from the boss. They have no connection to your boss, so they cannot really get anything out of this. Now we'll see this one, Mariam, Abu, and Siti. Siti will help Abu, Abu will help Siti, Siti will help Mariam, Mariam will help Abu, Abu will help Mariam. But you see here, boss can ask favors from Siti, but Siti cannot ask favors from boss. Although you are connected with Abu, this click here is irrelevant to your cause. So these two cliques or groups of people, they will not help you. They cannot help you. They cannot achieve your goal to get that promotion. Jack here is one of the noise. He cannot help you with any way. Okay, he cannot help you. You cannot help him. He doesn't want to help you at all. So the only people that can help you are these two, Johan and Samad. So in a network sense, I'm talking about network science here, where we talk about abstractions, using this as a paradigm and strategy and visualization. Raj and Ong, you have to remove them. They will not contribute. In fact, they will slow you down. Maybe they will ask you for that promotion. So if you don't want that, then you have to remove them. Mariam, Abu, and Siti as well. So the only way that the boss can see you is through Johan and Samad. Now, this is one example, trivial, but still a bit controversial, but still this is one of the many ways to use this large field of network science into something this small. I do have to say though, this is not a good way to go through the ladder. But the point here is you can use network science for something super controversial as this one. Okay, so just now I'd like to go back to this one. This is also another way to abuse network science. Since you have skills of data science, you have skills of business intelligence. This is where the ethical issues come in. You now have a mathematical representation of relationships. You know that it's very precise. You know that you can exclude these people, you can exclude these people. This is ethical issues. Whether or not you want to approach this or you have discovered something like this, this is your choice to make as a professional. Okay, so this is something bad data as well. Okay, so now I will talk more on back data after this. What we want to talk about return of analytics in the industry. Why is it returning? Okay, again, I said how network science is used as an abstractions, as paradigms and strategies, as visualizations. I need to give you another example for this one. I have a very young cousin. He was asking me what's the difference between a duck and a goose. He was saying that their feet are the same. So I told him, okay, you don't really have to focus on the feet. Just focus on the upper body and start comparing. And you compare on my right side here, you see a network. Compare with other birds that you see. Are they the same or not? The furthest apart from this particular bird, duck, then you know they are not the same. So this is one example of abstractions, but then he argues back. But I want to compare the body and the feet. I asked him, why do you want to compare with the feet? It's irrelevant. You said so yourself, it's the same thing. So there's a back and forth of debate whether or not the feet should be compared. And you're probably wondering what's the point of this example. I'll show you an industrial example later on. But just focus on why there's a debate on this particular data. Okay, so now the industrial example I'll give you is reports, the development of a software that generate reports. When I talk about reports here can be financial reports. It can be any types of very complicated business reports. Normally, this is auto-generated by software. So that software, if you want to release that software, you have to do defect analysis. You cannot release software that are defective. You'll get sued by that. Okay, so I'm going to give you examples of how networks are being used for this and how we have gained from it. And remember the dark example just now, reports. So this is a very complicated report. It is very multidimensional. Multidimensional means here you look at the new order details, the actions, the report at the bottom there. This is very complicated to build. I'll give you another example that everyone is familiar with, hopefully, which is your taxation form. This is an old form. The new one, I'm very sure everyone is aware of that, hopefully. If not, then there's an indication that you did not pay your tax. So the current form, whether or not the new form or the old form, behind this report is very complex logic. To develop such form requires a lot of knowledge on the business, which is taxation here, and the laws of Malaysia, and obviously coding, because you have to code the system. Okay, so who does this? There are two roles here, the developer and the business analyst. Sometimes some companies will merge these two, so the developer or the programmer will be the business analyst. Now, what do I mean by business analyst here? The business analyst is basically a role where they will find out if that software is going to solve any business problems. If this is a business problem, for example, the COVID case, how do we manage them? For example, one application is MySejahtera. Whoever develops that is actually probably a genius. He has identified there's a problem, then he thinks that there's a value to it. So he analyzed the competition and he asked the developer to develop it. Now, this looks really trivial, but there's a problem here. What's the problem here? The BA, we call it business analyst, they will think of the price, other stakeholders, for example, the MySejahtera, who are the people that will be using this? Do they even know how to use it? And what kind of phones, what kind of platforms? The value, is it free? Is it chargeable? Who's going to pay for it? What is the rate? So the BA has to determine it. The developer, however, don't really care about these sort of things because these are irrelevant to them. They only care about the codes, how they scale. And right now we have scaling issues with the COVID-19 vaccination program. There are some errors in that software. We don't really know what's the error. Maybe it's a scaling issue. Scaling here means that how you grow the software. How you maintain the software is another one. And technology, this tree alone is complicated enough for one person. But the problem here is that there's a chicken and duck problem. The BA wants all of this to be fulfilled. The developer would say that that's not reasonable because we cannot build such software at such cost. So there's a bickering around. They don't understand each other. They blame each other for making the wrong requirements, making the wrong system. So how do we manage this, and how network science is relative to this? Now, remember the dark problem, and remember the abstraction criteria that I said just now, that abstraction is used in network science. Okay, so instead of you focusing on the feed, for example, the BA is too focused on the price, the developer is too focused on the coding, focus on what's important. For the dark problem, don't focus on the feet. The feet are the same, no matter what size it is. It's the same shape, but the body itself is different. So you try to make that connection. So you show them these are the only things that we need for the time being. Okay, and let's talk about it. So this is how network science is used. Instead of focusing on irrelevant information, we focus on the information that we need and make connections out of it. So in terms of the development and the BA relationship, this is one example of a network implementation. These are obviously, these are nodes here. This flow is basically telling about something about data collection and processing. You don't have to go through them. It's a flowchart that shows how a particular software should behave. And this network is actually being used to communicate with multiple developers, saying that, okay, this part here is something that maybe can be done within the first week. This one can be done within 2 months, and this 3 and 4 can be developed in maybe 1 year. So you can tell the BA, okay, these are the costs, what do you think? Because they have understood what is required, and they have understood that this can be partitioned into small chunks of feature, and they can release it one by one. Okay, so once they have communicated to the BA, hopefully the BA will agree to the particular development work, because the BA has to determine timeline. But the developer now knows that through this graph, I have partitioned the graph, and this is the timeline that I can give to you. So it's clearer now, instead of just telling the developer, I need this and do it now. So this is an example of how we are doing it right now. We really analyze the network, we partition it to sub-networks, and we say, okay, what do you think? Can we do the first one? Can we do it the second one? Do we need more information? So this is one example of how network is used to develop software, really. Okay, so defect analysis. Now, you have the BA and you have the developers. Who determines this is releasable and it can be used? And I'm actually part of this team. We use networks to identify defects and whether or not it's fulfilling what the BA actually wants. Sometimes even the BA doesn't know what they want. They got confused with so many requirements that we need to tell them that, oh, okay, based on your network, you say this, but you are saying something else. So this is where this team actually is in charge of this. It's not suka-suka release software. If you see software that are really buggy and crashing, they probably don't have a team like this, or the team is not really that good. But how do you do defect analysis using networks? I know a lot of you have at least basic coding, and you know coding is actually very tough. But even in school and stuff, imagine industry, you are talking about millions of codes. How do you determine that software is releasable? Which part of the system should you try first? Which part should you validate first? Is it what exactly you want to validate? How do you know to determine this sort of thing? So this is where network science comes in again. So this is one example. This is a real example, by the way. So we have a middle node here, generate web test. You can see there are 4 smaller nodes: navigation, preferences, input, and syntax. So what the team, those release team, they will look at like this. So they will say that, okay, the right side, the top right is easy. One day you can do, because you have to just click the back, refresh the bookmark buttons on the browser. That's very straightforward, right? And the right side bottom is also easy. This can be automated. The left side is very critical. If you have a JavaScript injection, you can just hack through your system, which is really bad. So you have abstract all those codings that you don't really need to see. You make a network out of it, and you see which one you have to see first and identify whether or not they have fulfilled the requirements and protect the company from harm. So this is how we use network for defect analysis. Okay. So I have given you 2 industrial examples, one for a report where the BA and the developer are trying to communicate with one another, trying to actually manage the requirements and how these two roles have to manage each other and how they can help each other using network science. I also have used defect analysis on how we manage large amount of codes and problems within the codes by using network science. So, so that's how it returns. We know that coding is tremendously tough. So it returns to us that, oh, we can use network science for this. Now, this is where it's like some sort of viral. One company says, oh, I use this, but then the other companies catches up. They also use it as well. So that's why you have a rise of analytics, in particular network science. Okay, so the rise of analytics, number one, is because of we are aware of bad data, also due to the advancements of technology, for example, cloud computing from computer science, as I told you just now. Another one I need to add is the awareness and for universities such as UKM, manpower. So now you guys are doing this degree in or masters in data science. We have the manpower to deal with the sort of things and the challenges facing us soon or now. So what are the challenges? In network science, network engineering is always difficult. Number one is the source. Where's the source? Where do you get this data? Unstructured, structured, and how do you construct the network? What kind of models, visualization models? That's a hard problem. We are still facing it today. So those students, please, when you go to the seminar, make sure you are very good at the concepts so that you can solve problems when you enter the industry. Second one is typical. Changes in timeline and moving directions. For the students, you cannot really change this. This is typical. Okay, you might have construct very large networks, but the company can change direction and that will just destroy a network. Did that happen to me before? Yes, it did. But then there are ways to actually understand why. First of all, experience. Second of all, if you don't have industrial experience, go through the literature and study them. That will really help you a lot. But it's a typical situation when the timeline change and the moving directions. What you can do is to accept the fact that it is what it is and get ready for it. Okay, now I need to go back to the first point, which is network source design model, so I can show you what I'm talking about. Okay, so remember the trivial example I gave you? This looks really trivial, but first part here is already unstructured data. In the industry, unstructured data can come from database, forms, for example, like literally physical forms, diagrams, opinions, reports, and feedback. So you have to massage those data and create multi-features inside some table. But for network, there are two fundamental features that you have to have, node and edges. Without this, you cannot have a network. So you have to do some extra massaging here to construct the node and edges. Then after that, you absolutely have to have the visuals. Without it, you cannot really understand what's going on with the data, and it defeats the purpose of having an analytics. One of the aspects of analytics is to see the data. Okay. So this is one example of using Alteryx in one of my pet projects. You see those green lines, those are input source. These are all massaging the data, making it from unstructured, structured to structured nodes and edges. And finally, on your left side network visualization, it comes out like this. So it's not that simple, but this is how we do it practically using Alteryx. Okay, what are they not telling me in the industry? But you, or even the academics, while you are doing research, those network visualization measures, notice that I did not talk anything about network measures. Centralized, network centralization, degree distribution, hubs, power law distributions. Rarely we use this. They actually use it, but they don't say hub. They don't say degree distribution. They say, oh, there are many cabang-cabang, or there are many connections, but they don't say degree distribution. So there's a lack of understanding of the terms here. Network predictions, I have never seen this one used before. This is something that I'm trying to use in the industry. Whatever you are reading, for example, if Dr. Fatima said, read these papers, what you are reading is very advanced. Right now, the industry is not even using the terms like hubs and edges. Those papers that your researchers are doing are basically really advanced. So you students, please spend time reading them. Big networks so far, no. Big networks, I mean talking about millions here. So most used for visualizations and abstractions, as you came from the software I'm talking about just now, reporting and defect analysis, we use them for visualizing the problems. We partition the problem into smaller chunks of problems and we try to solve it using networks. Oh, and this is for those students at the bottom, the line. Trust me, you are really far ahead. This is something that you have to trust me because I'm also in this area. What can I do to avoid problems? Students, you have to get the definitions correct. You have to understand the literature. You have to understand the background. A lot of people out there don't know these sort of things, and you are the continuation of this knowledge. Okay, the visuals. Visuals are always important. It does not matter if your network is the best of them, but if you cannot present it, then there's no point. You have to remember that people are always going to question you, what is the value of this? You cannot tell me what is the use of network science. You cannot use certain words like abstraction. Maybe they don't understand what abstraction is, so you have to actually simplify it for them. I use abstractions. I know most of you know what that means. Conclusion, we are talking about network science, the importance of strategy and business intelligence, applications of networks in absolutely everything, and challenges so far. Q&A. Almost 1 hour. Okay.
Thank you, Zuhri. Very interesting. Even analyzing how to get to the boss, eh? So I wonder how you got into this. So this is an interesting question. Tak apa. Nanti kita bincang kemudian.
Dr. Fatima, I chose not to comment on that situation because I don't know if it's real or not. Oops.
Yes. But I understand what you mean because when I was doing my attachment at Maybank also, I was telling them to analyze people using relationships in order to make sure that they would optimize their allocation of job ke task ke along those lines lah. Yeah. So anyone has any questions? Yeah.
Oh, yeah, Dr. Fatima, I just want to add that network. Just now I gave example. I just want to relate to bad data because that is actually unethical. You are really removing your friends just to get a promotion.
Exactly. Yeah, so we have that issue also because I am analyzing my students' data. So we also it's confidential, right?
Yes.
So a lot of aspect to take into consideration. It's also the same with prediction as well, right? Because
Yes.
so it doesn't mean it will happen. So sometimes if you predict that these students are very close friends to each other, doesn't mean that they will copy each other in the online. For example,
Yes.
just to illustrate how difficult it is actually to be really ethical. So with great power comes great responsibility. Ada soalan?
Aku tak payah minum.
What software do you refer to when doing network science, Zuhri?
What software? I love R. So basically, the question is for construction of networks, right? Is that the root question?
Maybe yang bertanya tu boleh reply. Oh,
Yeah.
dia ada nombor metrik je. P10, P106902. Nama dia.
Ya. Saya tolong jawab ya. Itu maksud dia. Betul.
Okay. Kalau okay, saya cakap BM ya. Kalau network tu susah, selalunya network kalau industri memang susah selalunya. Saya akan guna R sebab dia banyak library dan dia senang nak belajar. Tapi kadang-kadang saya tak guna pun R, saya guna Microsoft Paint je sebab saya nak make a point to my boss. So this is the connection and that's the connection. And literally saya cuba nak tunjuk dia a different paradigm or a different viewpoint. So guys, you tak perlu pun advanced tool kadang-kadang. Kalau you nak tunjuk konsep especially with your boss, you kena cepat tau. Tak boleh nak tunggu lama.
Okay, so I think what Zuhri is trying to say, it is the network mindset tu yang very powerful because you can describe it. Satu conteng je, lukis macam ni je dah boleh faham.
Betul.
Tapi ramai yang gunakan R dalam ni yang saya tahu, saya sendiri pengguna R.
I love R.
Tengok love lagi. Banyak orang statistik kat sini, mereka mesti setuju.
Senang nak guna.
Okay, apa cabaran baru dalam bidang network science?
Ya,
Dalam industri.
Dah, sebelum tu ada soalan lagi. Sebelum tu ada satu lagi soalan.
Saiful Izwan. Banyak pensyarah kita juga berminat ni.
Yes.
Saiful Izwan ni pensyarah kita, tapi dia banyak analisis financial network juga ni. Any app product that bukan financial network lah, financial time series lah. Tapi mungkin boleh network kan nanti Saiful kan. Any app product that has been successful, any app or product that has applied network science, I think is the question.
Ada banyak. Dari 2013 lagi, dia orang guna network ni mostly for visualization. So contohnya telecommunication, ada software tu, dia akan ada satu part of the screen, boleh tak saya lukis benda tu supaya semua faham? Boleh nampak pen tak?
Tak nampak.
Tak nampak
Belum. Nak share the whole screen ke?
Kena share the whole screen.
Yeah. Share again, share again. Okay. Alright.
Macam ni Okay, boleh nampak Itu untuk the lecturer who's interested to know the applications of software that has been released using network science, right? Is that okay? Is that correct?
Yes.
Okay. So apa yang kita nak, katakan, ni saya lukis ni. So students, you tak payah pun fancy tool. Ni pun dah tunjuk, ni dah cukup ni, tunjuk orang. Ni antena. Antena. Dia akan bagi data tau. Data. Ada satu software tu, apa dia buat, dekat dalam software tu ada satu menu. Dalam menu tu, situ dia akan lukis satu node dan situ ada business logic dan banyak cabang-cabang kat sini. Dia buat macam ni, dia buat macam ni. Lepas tu satu ni dia pergi sini, satu ni dia pergi sini, satu ni mungkin dia ada more processes. Ni network tau. Tapi apa dia buat, data ni raw data, binary data. Betul, serius. Ni kosong-kosong yang kita nampak kat the matrix tu. Apa dia buat, dia akan datang ke ni sebagai input. Yang visuals tu dalam ni, dia akan attach script tau. Contohnya R contoh Sini ada R, sini ada R, sini ada R, sini ada R, sini ada R. Dan dia akan buatlah apa dia buat. Contoh sini massage data dan sini pergi ke billing. Contohnya ni antena Maxis. Maxis hantar data, contohnya Dr. Fatimah borak panjang. Data. Hantar ke sini, dia akan massage data tu, dia akan pergi, dia ada buat if else, pergi sini dan dia akan buat report lah. Dia akan hantar ke user. Ini ada, ni visual dia. Dia dah memang embed kat software tu. Dan apa dia, mediation system. Memang dah lama dah ni, memang benda tu dah lama ada.
So saya rasa dia menjawab juga soalan Sabri ni. List the names of companies in Malaysia that use network analysis. So awak tahu tak telecommunication company kat Malaysia memang pakai macam ni ke?
Ada, ya. TM. TM pakai.
Dan saya pun pernah jumpa personally yang daripada syarikat telco yang lain. Mereka kata mereka memang pakai. Tapi mungkin dia tak panggil network, dia panggil graph analytics or something like that lah. Tapi along the line lah, graph theory based.
Betul. Industri ni dia ada banyak term. Graph theory lah, graph je lah, diagram je lah. Kadang-kadang dia redefine benda tu. Sebab dia nak market benda tu kan.
Yeah. And then dia rasa macam something new. Tapi sebenarnya mungkin itu dah lama.
Dah lama dah. Tak, ini the one that I'm showing right now. This is nothing new.
Okay. Thank you for that question, Saiful. So kalau financial networks, maybe dalam PhD Zuhri lah dia nak buat visualization. Ada soalan daripada Imran. Imran pun PhD student. Dia tengah tengok networks social media Malaysia. Dia tengah cuba nak buat networks rasanya. Dia kata apa cabaran baru dalam bidang network science in industry. Soalan Imran.
Okay. Soalan tu susah nak jawab tapi saya boleh jawab. Sekejap. Okay, boleh nampak slide saya?
Boleh.
Dia buat social media
Rasanya lah extract data daripada Twitter last time I tanya Imran, tapi itulah dah lama tak jumpa PKP. Apa khabar Imran? Harap sihat.
Okay, Imran ni high level lah sebab saya tak tahu specifics you punya research problem or research statement. Tapi in social media, saya ada buat Twitter analytics before. Nak dapatkan data tu dah susah, awak kena scrap data tu kalau awak ada lah. Itu kena programming. Lepas tu awak kena buat awak kena transform daripada unstructured data ke structured. Dalam structured table tu ada multi features. Awak kena analyse benda tu. Lepas tu awak kena translate ke nodes and edges. Dan sekarang ni soalan yang contohnya lah, Dr. Fatimah ataupun panel member tanya, kenapa awak guna nodes and edges tu? Apa relevance? Dia akan sama macam industri. Macam apa value nodes and edges yang awak guna tu? Ada point ke? Ada significance ke? Sama je. So have to be very careful lah how you define the nodes and edges. That's the challenge.
Yeah.
Sebab walaupun awak dah buat unstructured, structured, lepas tu nodes and edges tu, sampai sini dia, diorang tak terima. Itu dah habis lah.
Betul. That is the challenge. Dalam kelas network science pun masa dia nak cari projek tu memang macam-macam cadangan ada, tapi kita akan kata nodes dengan edges dia doesn't make sense. Quite a few times lah.
Lepas tu kita boleh sambung, what is the value that you are trying to do here? What is the solution? Why do we need to care for it?
True. That is the storyline lah.
Yeah.
Perlu kita ceritakan. Kita sampai ke cerita. Okay, so Sabri pun pelajar PhD juga. Dia buat analisis data financial network time series juga ni. Saya co-supervisor dia bersama Prof. Salmi. Dia kata what other real application problems in business sector which are handled by network representation selain daripada telco lah kot. Tak tahulah dah menjawab soalan Sabri ke belum, sebab dah bincangkan. If you want to ada apa-apa lagi contoh yang Zuhri rasa nak berikan?
Okay, so saya dah bagi telco, saya dah bagi defect analysis, saya dah bagi coding dengan BA tu.
Tak apalah, okay. Kita harapnya menjawab lah. Kalau Sabri ada soalan nanti tanya lagi Sabri. Okay, Muhammad Haziq ni ditanya, how did you become interested in network science?
Ada banyak sebab. Satu, sebab saya masa tu Dr. Fatimah saya nak prove there are alternative than machine learning. Saya ni memang a proponent of a detractor for machine learning. Sebab bagi saya ada sebab machine learning ni expensive. Lepas tu certain research tak define learning tu apa. Kita tak tahu apa tu AI. So saya nak prove ada alternative analytics model is far more cheap than machine learning.
I see. It came down to cost lah, tak sangkanya.
Yeah, cost. Everything is cost for me. Itu yang saya cakap, saya cost. Yeah.
I see. You mean sebab machine learning tu dia kena hadamkan banyak-banyak data dulu. Baru dia dapat keluarkan dia punya analisis, dan analisis tu kita tak boleh nak terangkan.
Betul.
Yes.
Sebab sekarang ni pun, yang network ni pun kita dah dapat dah results. Network kecil kan?
I see. But this is memang the perennial argument lah. Saya pernah hadir ke conference besar di antara laureate computer science dengan mathematics kan. Dekat Heidelberg tu, memang itu argument dia yang orang akan bergaduh. Dan conference besar, kompleks sistem sedunia tu memang itu bendanya yang orang akan bergaduh. Orang yang anti machine learning dan orang yang pro machine learning. Tapi kita dekat UKM ni agak harmoni. Kita gunakan je semua selagi mana kita rasa membantu lah. Tapi betul lah, of course saya bias terhadap network science lah sebab saya mengajar kan. Tapi machine learning pun kita gunakan juga.
Ya, sebenarnya kan network science ni nak menghala ke machine learning juga. Sebab bila network tu dah besar, kita boleh guna machine learning tu untuk study the structure.
Yes, true. Dan kita boleh gunakan bersama-sama kan.
Ya. So saya tak boleh serang je machine learning. Eventually saya kena guna juga.
Betul. Okay. Itu interest dia. Mungkin Mama Haziq nak buat PhD ke, get in touch Mama Haziq ni. Tanta dah pensyarah daripada Muslim, minta maaf saya gurau-gurau. Saiful Izzuan lagi. Okay, Dr. Saiful lagi. What is the best library in R for this analysis based on your experience? Kedua, any small startup that you know apply this concept that could potentially be huge. Ni ada cadang nak buat startup kot ni. Dr. Saiful,
Wah,
silakan.
saya rasa doktor ni macam ada business vision. Sekejap, saya nak jawab yang library dulu. Saya tak ada anything saya suka, saya just guna je. Yang bestnya R ni, dia bukan macam Java atau C++. Java and C++ ni dia heavy tau, you kena faham machine architecture. Contohnya pointer, kalau you all ingat pointer tu is basically a keyword yang akan pegang memory address. Memory address, ya Allah tuanku, itu pun nak tahu ke? Tapi itu benda tu penting untuk performance. R, benda-benda tu tak perlu sangat nak tahu. Itu sebab saya guna R. Kalau saya nak, Dr. Fatimah, maybe in future, kita nak study the analysis of bit networks and its performance, maybe kita kena guna C++ lah.
Yes, true. Some of my friends yang pergi million tu memang dia kena upgrade lah. Dia kena drive sebenarnya yang besar. But untuk yang kita nak terangkan kepada orang yang ringkas-ringkas, mula-mula saya memang cadangkan guna R lah dulu.
Apa-apa kita start kecil, baru kita besar.
Yes.
Okay, yang company kecil tu, saya tak berapa ingat company tu. Kalau saya ingat saya beritahu. Tapi ada. Saya sama ada saya tak ingat atau saya tak boleh beritahu. Itu je saya nak cakap.
Zuhri ni banyak PNC punya benda ni.
Betul.
Alright, tak apa, nanti Dr. Saiful mungkin kita boleh bincangkan kemudian, dan kita yang buat startup lain yang akan berjaya, insyaAllah.
Bawa Zuhri sekali.
Termasuk. Kita ada banyak PhD student kita ni yang dah nak habis ni. Kita kumpulkan mereka. Yang bertanya-tanya soalan ni pun banyak ni PhD student ni.
As a strategy doctor, dah fikir dah?
Macam tu lah sebenarnya, saya ada niat. Masa depan. Okay, Sabri semua ni dah nak grad dah ni. Okay. Hazwani Khalid, what are the ingredients of a good network scientist?
Ui, soalan. Ingredients of a good network scientist. Number one to me is understanding the concepts. Okay, kalau awak tak boleh define network, awak tak tahu beza network dengan graph, awak tak tahu network science tu apa, tak tahu graph theory tu apa, for me, Dr. Fatimah, you are not really a good network scientist. Scientist lagi tu nama dia, tapi tak tahu the difference between complex network science and sort of things. So for me, please try to understand the principle first. That's for me lah.
True. Principle kan, so the basic underlying mathematics lah kalau saya faham, ikut saya.
Yes. Sebab
ada soalan, Zuhri nak jawab lagi ke?
Yang ni,
Boleh.
nampak kan diagram ni? Network science ni banyak guna graph theory tau. Dia asas graph theory. Kalau awak tak faham graph theory, awak tak boleh buat network science. Kalau awak tak faham graph theory, macam mana graph theory digunakan oleh computer science, awak tak boleh buat network science. Kalau awak tak faham statistics, lagi tak boleh buat network science. So inilah prinsipal dia.
So tu berkait dengan soalan Dr. Almi pula. Why did you choose mathematics department to do PhD rather than computer science department? If personal, Dr. Almi kata. Sebab tahu Zuhri rasa.
Okay, sebab saya suka mengkaji. Sebab benda network science asasnya graph theory, bukan computer science. Walaupun saya dalam bidang computer science. So saya nak go back to the roots lah. Nak kaji balik roots. Itu sebab saya cakap tadi, principle. Go back to the principle and expand from there. Computer science pun expansion of applied maths.
True. The father of computer science pun Alan Turing. Dia memang pure mathematician. Father of computer lah.
Computer science dia bukan pasal komputer pun sebenarnya. Dia pasal mechanical automata. Automata tu adalah apa-apa mesin yang boleh buat something. So itulah computer science. Dia banyak guna graph theory.
I see. Okay. Alright. Kalau dah tak ada apa-apa lagi
Dr. Fatimah, saya lepas dulu deh.
Boleh? Silakan.
One question. Yeah, because just now you said what programming tremendously difficult. Is that the reason why you come to mathematics?
Dia terror tu, Dr. Leong.
Dia kata tremendously difficult. Kenapa you kata macam tu? Student dengar takut tu nanti.
Oh, coding
Yeah, coding. You say it's tremendously hard work. Tremendous.
Oh, coding. Sebenarnya coding. Students jangan takut Okay, saya
berapa ribu, berapa million codes, berapa lines of million code of line that you have written that make you say it's difficult.
Dia difficult dia sebab bukan difficult. Dia it's a job.
It's complex, yeah, I know.
It's complex. Bila kita buat assignments, it's just assignment. Bila you buat dengan orang kerja luar, awak kena kerja dengan orang lain. Dan awak kena berinteraksi dengan diorang. Diorang ni kadang-kadang sekarang ni lagi pandai pada awak semua. Coding diorang lagi power. Jadi kadang-kadang kita rasa macam kecil sangat. So itu you have to take into consideration. Tapi you keep on trying to improve lah.
So tak apa, jangan takut
Jangan takut. It's normal. Alah, memang bidang sama je.
Dah kerja kan, takkanlah senang kan macam tu.
Adanya.
Okay. Survive kan, dia survive. Yang penting you survive. Thank you.
Do you still have time? Tiba-tiba masuk pula soalan-soalan ni. Ada pula nak tanya, asking for opinion pula.
Okay.
Tapi ada soalan daripada Dr. Hafizah ni, UIA from our alma mater.
Assalamualaikum sister.
Dia pun, kalau awak join meeting yang network science tu ada Dr. Hafizah ni, insyaAllah. So tak perlu bincang kat sana, mungkin boleh jawab dalam meeting kita punya financial network nanti. Tapi ada seorang pelajar UKM ni, what example of financial network that you ever experience? Dia tanya.
Nama dia Katie. Nama dia Puan Katie.
Saya tak faham soalan dia. Apa soalan dia?
Mungkin jenis financial network kot yang pernah Zuhri gunakan ataupun analyse kot.
Oh, banyak. Salah satu dia saham.
Saham, yes. Kami pun analyse saham, group financial network dekat UKM ni yang insyaAllah Zuhri bercadang nak join ni, analyse saham lah. Stop. Okay.
Saya banyak buat decisions tengok kat hub networks tu. Kalau banyak hub saya tak pergi sana. Takut saya.
Oh, sebab dia terlampau penting. Anything happen, dia runtuh.
Dia boleh collapse.
I see. Okay, Kai Siong missed the introduction of this talk. Kita boleh bagi your teaser kejap lagi kot dekat Kai Siong. Dia nak tanya your background.
Tu ada kat teaser.
Kita bagi link dekat teaser. Saya kena cari balik.
Saya ada.
Terima kasih Dr. Leong. Ada yang nak tanya one last question ni, Aisyah Zaidi ni. Nak bersuara ke?
Yeah. Okay, so hi. Thank you for the great sharing just now. So I think this is rather like asking for your opinion, but there was like a documentary last year that was released called The Social Dilemma. I don't know if you have seen that, but it was about it demonstrated how the data was used to exploit us. And I just want to ask your opinion that shouldn't we put like more regulation on these big companies because somehow they are using our data against us and making profit out of it. So yeah, I just want to like see how you think about that topic.
So
thank you.
You're asking me if whether or not Parliament should enact a law for it?
Yeah, kind of something like that.
Absolutely. It's my information. Who are there to use that for business decision? That's my opinion of it.
Oh yeah, okay. Because like sometimes there are some professionals that in the field like supported that. So yeah, it's good that you.
I'm uncomfortable with that. They have to ask my consent first.
Yeah. Okay. Thank you.
How about you? What do you think?
Yeah, I'm totally against that. Yeah, I really like because I think the fact that they're making profit out of it and not giving us anything back, it seems like very capitalism thing.
Plus, they might use that against us.
Because especially like they use the data like sometimes the Facebook case yang against Mark Zuckerberg, that's like the biggest example I think, but I mean that's just yang exposed. The one that has not been exposed are like mind blowing and
Like
scary.
MySejahtera, they track your location, right? So we don't know.
Yeah.
what they use.
Yeah, that's like for status. Okay. Okay, another thing, like, do you think like I think in the US they are starting to realize this, and there was a movement made by one of the employees in Google, the one that created Gmail. So like he stopped working at Google, and then he created another company to push some bills against using data. And do you think in Malaysia like we can do something like that?
Wow, that's a very good question, but it's going to be very difficult for me to answer that question. In Malaysia, from my opinion, from my own experience studying computer science, in terms of the law, we are very far late ahead. We are piracy is still a problem in Malaysia. Even that we cannot solve at the moment or manage properly. How about big data analysis, right?
Yeah, but I think it's important that we as a community like realize this first, and then we can push to change the law or something like that. So it's good that people, professionals such as you, want like against this.
Actually, the very fact that you're asking this question, and I know in social media, people are very angry and started questioning these sort of things.
Yeah.
So it's a good thing the government is. I hope they are listening.
Yeah, I hope so too. Okay.
Good
Thank
question.
you. Okay.
Yes, I hope they are listening. I'll post this on YouTube nanti. So bolehlah kita nak panjangkan kepada government ke apa ke. Tapi
Yeah.
no. But thank you for that point. Betul. Macam dalam documentary tu katalah, if you're not paying for it using money, you're probably paying for it using your data lah, kan? So apa lagi? Ada tak soalan lagi? Dah tak ada soalan saya rasa. Okay, so kalau tiada soalan, Dr. Leong nak minta sesi bergambar. Kalau Zuhri tak nak buka pun tak apa, tapi Dr. Leong nak minta bergambar, mungkin ini sebab nak simpan as record kot sebagai student punya aktiviti. Masuk official kan Dr. Leong? Okay.
Terima kasih banyak. Sampai tu kita ucapkan banyak terima kasih kepada Encik Zuhri. It's a very good talk. Very interesting. It's a very knowledgeable as well. But time does not allow us to dig further on your experience. Worldwide experience, dia ada macam-macam pengalaman lagi kan. Okay, jadi sekarang kita sesi bergambar. Siapa yang berminat boleh buka kamera untuk sesi bergambar sekejap. Saya akan tangkap gambar.
Okay.
Nanti mana tengok galeri besar ya. I have to use the large gallery view. Oh, saya sendiri belum buka lagi. Okay. Okay, boleh. Siapa-siapa nak join? Siapa lagi nak tolong tangkap gambar pun boleh. Large gallery view. Tak ramai lagi. Dia kena ramai dulu. Mungkin Zuhri kena tutup dulu ya presentation dia.
Stop sharing
Stop sharing ya, please.
Apa, thank you very much Zuhri. Nanti insyaAllah di masa hadapan kita buat lagi sesi berbincang macam ni kan, untuk berkongsi-kongsi idea dan memberi insight kepada industri untuk para pelajar kita lah. Semoga bertambah baik lagi lah industri kita. Dr. Leong snap ya Dr. Leong?
Saya akan snap. Siapa-siapa pun boleh snap, ramai tu. Pensyarah pun ramai. Tak ramai lagi tak cukup lagi ni. Berapa? Ada lagi kan? Berapa ramai yang bukan? Dekat ni baru tak sampai lagi 49 lah.
Nampak muka Imran, Kak Adila.
Imran, ya. Hesiong tak nampak lagi.
Sekarang gelap.
Okay. Siapa buka? Saya snap, siapa-siapa nak snap pun boleh juga. Tolong saya snap. Snap satu dulu. 1, 2, senyum. 1, 2, 3. Imran dah senyum tu. Okay. Dr. Almi. Okey. Sofi jelas lah. Siapa lagi? Nak masuk? Sekarang ada lagi ni. Belum ramai lagi tak dapat masuk. Dah masuk semua? Ke belum? Nak tukar yang lain ke? Nak. Tapi belum penuh lagi, belum sampai 49 kan? Saya rasa dia boleh sampai 49 orang. Tak pasal tukar kepada together mode, tengok macam mana. Tukar kepada together mode. Masih tak ramai kan? Kamu nampak skrin saya?
Tak nampak Dr. Leong.
Saya share. Sekejap, saya share lah. Okay, oops. Mana?
Okay.
Oops.
Oh, Dr. Leong nak letak dekat kerusi. Okay.
Ni kursi. Ini tak penuh lagi. Tak penuh lagi masih. Ada banyak orang tempat lagi. Oh, kenapa yang depan dah cerah sangat tu? Sorry. Tak apa, tukar dulu. Saya tukar background. Tukar change scene. Boleh tukar ni. Yang putih lebih baik. Okay. Apa sudah. Oops. Siapa lagi nak masuk? Sudah. Dah. Okay, dah. Nampak.
Ada Dr. Mibah semua.
Ceramah kita tak nak masuk dah. Tak apa. Itu sudah kacau. Yalah, dia mungkin next time dia kata next time. Apa 1, 2, 3. Mana student saya datang tak masuk? Student pelajar okey masuk 1. Masuk lagi yang lain. Lagi pelajar kita. Saya simpan dulu. Ikut ni yang gambar yang kita ada. Kalau terlupa nanti hilang lah. Okey, siapa lagi nak masuk? Siapa lagi? 1, 2, 3 sebab masa tak mengizinkan. Hari ni hari Jumaat lah. Jadi bagi 2 minit lagi. 1 minit lagi siapa nak masuk? Cepat. Siapa boleh snap? Oh, dah jadi kabur pula ya. Skrin saya kabur sikit nampak. Kenapa dia jadi kabur? Network. Okey, sekarang dah better. Saya ingat network something kan. Apa? Alright. 1, 2, 3. 1, 2. Fatimah nampak gelap sikit lah.
Tak apalah. Lighting memang masalah sikit, so tak apa.
Section lah. 1, 2, 3. Oops. Dah. Nanti saya tengok jadi tak. Tengok boleh nampak kan, kamu nampak skrin saya ni. Saya masuk dekat sini jadi tak. Di kehadiran ada di ruangan chat ya. Ruangan chat ada link ke kehadiran, Google Form dan juga pautan QR code ada dekat sana. Both is available. So thank you very much. Terima kasih banyak Dr. Fatimah.
Okay, kita tutup majlis
Ya, saya stop sharing ya. Okay.
Tutup majlis sampai kepada suratul as. Terima kasih sebab sertai. Kita berjumpa lagi di lain perbincangan insya-Allah. Assalamualaikum. Salam sejahtera.
Okay, bye-bye guys.
Thank you very much. Terima kasih. Thank you very much.
Thank you.
Sama-sama. Terima kasih semua.
Terima kasih Dr. Fatimah.